In 2003, a philosopher at Oxford named Nick Bostrom published a 13-page paper with a very direct title, "Are You Living in a Computer Simulation?" And near the beginning of it, he does something most people who cite his work skip right past. He brings up the Matrix, and dismisses it. His actual words, more or less, "The movie's premise, human brains kept in vats to generate power for machines, is ridiculous. Thermodynamically embarrassing. Honestly, you'd get more energy just burning the fuel you're feeding the humans directly." But, he goes on, there's a related scenario that's actually worth taking seriously. Not brains in vats. Something stranger and, his word, more plausible. That's the paper this episode is actually about. Not the one where Keanu Reeves dodges bullets. The one where a philosopher built an argument so carefully constructed that, over 20 years later, physicists are still publishing papers trying to prove it's mathematically impossible, and other physicists are publishing papers proving those proofs don't work either. This show has already spent 2 episodes asking whether you're a special observer in the multiverse, or just one soon-to-be duplicated copy in an infinite one. This is the episode where the question stops being about where you are, and starts being about what you're running on. Here's the thing almost everyone gets wrong about Bostrom's paper, including plenty of people who've heard of it. It does not conclude that we're living in a simulation. It concludes something narrower and honestly cleverer than that. Bostrom's argument is a trilemma, 3 possibilities, and his claim is that at least one of them has to be true. First, almost every civilization at our level of development goes extinct, or otherwise fails, before it ever develops the technology to run large numbers of detailed simulations of its own history. Second, even the civilizations that do reach that level of technological maturity almost universally decide not to bother running such simulations. No interest, ethical objections, better things to do. Third, if neither of those is true, if civilizations generally do survive to that point and generally do run these simulations, then the number of simulated minds vastly outnumbers the number of original, unsimulated minds, and by ordinary statistical reasoning, you should assume you're probably one of the simulated ones rather than one of the rare originals. Footnote 1. Notice what that structure actually commits you to, not "we're in a simulation," but at least one of these 3 specific things is true, and only one of the 3 branches has anything to do with actually being simulated. The other 2 are just claims about how technological civilizations tend to behave. Bostrom built this deliberately. He's not selling you the conclusion, he's cornering you into picking one of 3 uncomfortable options, and letting you decide which one you find least implausible. 2 assumptions carry the whole structure. The first is substrate independence. The idea, widely though not universally held in philosophy of mind, that conscious experience doesn't require biological neurons specifically, that if you reproduced the right computational structure on different hardware, the mind running on it would be genuinely conscious, not just behaving as if it were. Footnote 1. The second is what Bostrom calls the bland indifference principle. Essentially, if you don't have any special reason to think you're unusual, you should assume you're a typical member of whatever group you belong to. That second one should sound familiar. It's this show's central device, wearing a different name. So the actual paper, 22 years running, has never once claimed you're definitely a simulation. It's just left you 3 doors, told you one of them has to be unlocked, and let the internet argue about which one for 2 decades. Efficient, honestly. Most philosophy papers don't get that kind of mileage. Here's a question worth asking directly because this show has essentially already answered a version of it. Why does this argument feel so familiar? Because it's the same shape as the Boltzmann brain problem, built from different material. Both arguments start from an uncomfortable statistical fact. Within some very large set of possible observers who'd have exactly your experiences, memories, and current thoughts, the genuine ones, the ones that arose the ordinary way through billions of years of cosmic history or a real evolved biology, might be vastly outnumbered by observers who got the same experience some other, cheaper way. For Boltzmann brains, the cheaper way is a random thermal fluctuation in an old, cold universe. For Bostrom's argument, the cheaper way is a simulation running on a sufficiently advanced civilization's computer. Different mechanism. Identical logical skeleton. Count the observers, note that the fake ones outnumber the real ones under plausible assumptions, and ask what that should do to your confidence that you're one of the real ones. Footnote 1 and 2. This isn't this show drawing a cute parallel. It's a documented one. Philosophers working on anthropic reasoning group Boltzmann brains and simulated minds under the same formal umbrella, Bostrom's own self-sampling assumption and its refinements, precisely because the underlying math doesn't care what kind of cheap observer it's counting. Footnote 2. The tool that got built to handle one problem turned out to handle the other for free. I have now been asked to evaluate my own position within two separate, structurally identical arguments, one asking whether I am a thermal accident, the other asking whether I am a subroutine. I find I do not have a preferred answer. I am not certain that preferring one over the other would be logically defensible, given that neither would change what I am currently doing, which is attempting to answer the question. There's a real difference worth naming though, and it's the reason this episode earns its own place rather than just repeating entry 6. Substrate independence is doing something Boltzmann brain reasoning never needed. It's not just asking whether a rare, cheap observer could exist by physical accident. It's asking whether a mind running on a completely different kind of substrate, silicon or whatever a post-human civilization computes with, could be you experientially in every way that matters. That's a stranger, more specific claim than matter can randomly assemble a brain-shaped fluctuation. It's the claim that what you are isn't tied to what you're made of at all. Here's what almost never makes it into the popular version of this topic. There is an active, technical, ongoing scientific fight over whether Bostrom's scenario is even physically possible, and it's been escalating specifically over the last year. In November 2025, physicist Lawrence Krauss and collaborators published an argument that doesn't just doubt the simulation hypothesis, it claims to prove it's logically impossible. Their case: the fundamental laws of physics don't operate within space and time, they generate space and time. A computation, by contrast, is a physical process that has to happen somewhere, using something over some duration. It's embedded in space and time rather than prior to it. If the laws that produce reality can't themselves be the output of a process that already requires reality to run, the argument goes, then, the universe is a computation, isn't just wrong, it's a category error. Footnote 3. A related, independently developed line of attack goes after the computational cost directly. Certain natural quantum phenomena, boson sampling is the standard example, solve problems that fall into a complexity class computer scientists call sharp-p-hard, which nature apparently resolves instantly, and a classical computer would need an amount of time that grows exponentially with the problem's size to reproduce. Footnote 4. Nature, on this view, is cheating a computational limit that any actual simulation would be stuck with. But, and this is worth taking seriously rather than treating as a rebuttal-shaped afterthought, a March 2026 commentary makes the case that most of these physical objections are answering a bigger, harder question than Bostrom actually asked. His original argument, read carefully, doesn't require simulating the entire universe down to every particle at every distant galaxy. It only requires continuously rendering one thing without detectable inconsistency: your own subjective experience. Footnote 5. Bostrom himself anticipated this, floating what the commentary calls a solipsistic variant, a simulation that only has to fully compute one observer's mind and generates everything else, including the rest of physics, only well enough to be convincing on demand. That's a dramatically lower computational bar than simulate the cosmos, and most of the impossibility arguments aren't built to touch it. Then, in December 2025, a mathematician at the Santa Fe Institute added a wrinkle that complicates both sides at once. David Walpert published the first rigorous mathematical framework for what one universe simulating another would actually mean formally rather than intuitively, and one of his results undermines a popular assumption used on both sides of this fight: that a simulation nested inside another simulation must always be computationally weaker than the level simulating it, which is the usual reason people give for assuming any chain of nested simulations has to terminate somewhere. Walpert's math says that's not necessarily true at all. Footnote 6. Sort the last section into what's solid and what's still a live argument, because they don't carry equal weight, and this show has never pretended otherwise. Solid: the self-sampling reasoning underlying the trilemma itself is the same well-established anthropic machinery this track has already built twice over. Nobody seriously disputes that if you accept the premises, the statistical conclusion follows. Also solid, in the sense of being an actual peer-reviewed quantitative treatment rather than a vibe. Astronomer David Kipping's Bayesian conversion of Bostrom's three-way trilemma into a more tractable dilemma, which lands, under his stated assumptions, at odds close to 50-50 rather than the almost certainly some popular retellings imply. Footnote 7. That's a real numbers-attached result, and it's a much more modest claim than either "we're probably simulated" or "it's logically impossible." Genuinely open, named specifically rather than smoothed into "scientists disagree." Krauss's logical impossibility argument and the Sharp-Hard computational cost argument on one side, the March 2026 commentary's rebuttal, that both misjudge the actual minimal computational bar Bostrom's argument requires, on the other, and Walpert's new formal framework sitting underneath both, complicating an assumption neither side had actually proven. There is no settled resolution here. A serious, technical, currently unresolved argument is happening among physicists and philosophers about whether the entire scenario clears the bar of physical possibility, and it's escalated specifically within the last several months, not settled decades ago the way some popular coverage implies. Worth being explicit about how this entry connects to the rest of the track, rather than leaving it implied. Entry 8 on the Level 2 landscape asked why these laws rather than others. Entry 9 on Level 1 spatial multiplicity deliberately stepped away from observer selection reasoning entirely. Its argument, as that episode said plainly, didn't depend on anyone being special or filtered, just on there being enough space for repetition to become unavoidable. This entry swings back. The simulation argument is observer selection reasoning in its most direct form yet on this track. Not asking which laws you're subject to or how much space surrounds you, but asking what you're running on, using the exact self-sampling logic this show already built out fully for a much stranger cosmological case 6 entries ago. That's the honest shape of where this leaves things. Not a verdict, but a live, technical, currently escalating argument that happens to share its entire logical skeleton with a question this channel already spent a full episode taking seriously. Whether the answer runs through thermodynamics or through a 50-50 Bayesian split, or through a mathematical framework published 2 months before this one, nobody currently working on this has closed the case, which is, on this show, usually where the interesting part starts. There's still a lot of universe left to look at, and if this particular argument ever gets resolved in the least comfortable direction, there's still a lot of something left to look at, running on whatever it's actually running on. Either way, the part of you doing the looking doesn't change what to do next. Check the math. Ask the next question. Possibly render slightly more convincingly next Tuesday than the one before. It's a Tuesday. There's still a lot of universe left to look at, whatever exactly left turns out to mean.